Hey everyone, I am very happy to introduce our guest for this interview segment today. Dick Wilkins is an associate professor of computer science at Thomas College in Central Maine and is a principal technology liaison for Phoenix Technologies. Some of our listeners may recognize that. If you booted a computer in the past 20 years, you may have recognized Phoenix Technologies come up on your screen. It's, of course, a USA-based system boot firmware development company. Dick is active in several international standards bodies and sits on the board for the Unified Extensible Firmware Interface, or UEFI Forum. He's a leader in the Institute for Electrical and Electronic Engineers, or IEEE, as we say. And in the Computer Society, he is active in the Association for Computing Machinery, or ACM, and the Project Management Institute, or PMI. He has over 30 years experience in the industry and has had several positions at some pretty big companies, including Hewlett-Packard, Microsoft, and Amazon. Dick, welcome to the show.
Thank you. I'm happy to be here.
Dick, my first question for you is, when we talk about UEFI, we've covered it on the show in the past in a security light, but what are some of the security implications, both threats and defensive implications for UEFI?
Well, as any platform firmware, it's an attack surface that the bad guys out there in the world might choose to go after. And so it needs to be protected and secure, just like any piece of software or firmware on your computer system. And UEFI is no different than any other piece of software, and it needs the same kinds of security mechanisms.
And so some people are kind of freaked out about EFI, and I've noticed that in some of the articles that I've read, where people are just like, "Oh my God, what we used to call the BIOS is connected to the world, and this is just a complete disaster for security." Can you kind of dispel some of those myths for us?
UEFI was developed. It was originally EFI, the Extensible Firmware Interface, as a replacement for traditional BIOS. And we try not to call it BIOS anymore because the traditional BIOS doesn't really exist. For many years, the firmware has been largely replaced by one of various variants. And EFI is not some evil interface created to take over the world or something. You hear all kinds of conspiracy theories and that kind of thing, that the old Wintel consortium of Intel and Windows, Microsoft, created this thing in order to take over people's computers and somehow constrain them so they could only run what Intel and Windows wanted, essentially, or Intel and Microsoft wanted. None of that is true. The forum that maintains the specification is made up of over 300 companies, including some of those, but large companies, large and small, and many of them contribute to the standard and have developed a really high quality, secure environment to start your machine up and get the OS loaded.
Yeah, and one of the first things when I think about security in this context is, well, I relate to my own personal experience where I would upgrade hardware typically in older systems that would force me to update what was then the BIOS, and I used to have to get those. Well, for me, it was 3.5-inch floppies. I'm sure for some it was 5.25, or maybe even older. Those methods of updating, booting on a boot disk and manually updating that code that was running on the hardware that was responsible for identifying the other hardware on the system. But today, if we have a better way, an easier way to allow people to update this firmware, isn't that a good thing?
Oh, absolutely. As firmware has gotten more complex over the years, supported many more devices, created and the hackers, the bad guys of the world, have been thwarted in many cases by the OS vendors and application vendors from attacking those systems. They've looked for other venues. And if there are flaws in firmware, you need to be able to update it, just like you could update your application or install, operating system patches and those kinds of things. So you really need to be able to do that on a routine basis, just for, as you said, sometimes new hardware support, but it doesn't have to be that. I mean, it can be security flaws that exist, other enhancements, improvements, speed ups, whatever. You need to be able to do that. And the UEFI specification provides a mechanism for safely doing that and securely doing that. So only signed, cryptographically signed capsules containing firmware updates can be loaded into your system, and the process is specified such that you can't do things like roll back to a less secure version of the firmware.
Yeah, and I've always thought that along those lines, an interesting attack vector and something that I think people were concerned about, but I haven't seen really pervasive in the wild, is that some malicious actor is going to infect the firmware, and then regardless of what you do in your operating system, they're going to be able to reinfect your operating system. Is that something that you talk about a lot in the forum and work to protect? Because that could be a very stealthy way to persist on a system if you're a bad actor.
As I've written a number of times in various publications and white papers and talk about in speaking engagements, the firmware is a very potentially dangerous place, in that if you can somehow get control of what's going on with the firmware, you've got total control of the box at that point. You can load anything you want to, you can spoof anything you want to, you can hide from the OS the fact that it's booting potentially in a hypervisor created by the attacking firmware, and when it thinks it's in total control of the machine, it in fact is being spoofed. There's lots of attack vectors, and a number of them have been demonstrated. I think we in general are very lucky that the bad guys haven't really attacked too many systems out there in the world. There have been a number of cases where firmware has been attacked, and I guess the most pervasive versions that I've seen have been denial of service kinds of things, where they've attacked firmware and changed settings or caused it in such a way so the machine would no longer boot, and bricked or turned machines into boat anchors, as we like to say. Those have been not widespread, thank goodness, but they have happened, and we need to make sure that they don't happen in the future.
Yeah, certainly early malware back in the day, that was, they didn't overwrite the master boot record, for example, or even, corrupt back then was the BIOS. Today, especially as we, talk about embedded platforms, it's, of course, because you have that flash chip and you have control in a lot of platforms over what's on that flash chip. If you start overwriting things, you can override, that code that's actually initializing the hardware, in which case we basically brick ourselves. It's not an attacker, but on the embedded platform, I think a lot of times it happens because, people are messing around and overwrite things that they shouldn't. Have you, kind of experienced that in the embedded world?
It could happen on any machine. I don't want to focus on embedded in that particular case. I think the issue at this point for devices, particularly up and coming, the widespread and widely spreading IoT space, those devices haven't up to date focused as much on security as they probably should have. And I don't want to go with too broad a brush here, because some have been very good, but too many of them have left themselves wide open for the kinds of situations you were talking about, where firmware can be overwritten and software loaded that was unexpected, and those kinds of things.
Yeah, I've often found, working with embedded systems, that they kind of skip that step of validating the code that's running on the chip. Is that just because they have a small code base to work with? In other words, the bootloader in this case, or whatever the mechanism will just basically load whatever you give it because there's no checks and balances to say you have to be running signed code. Is that just because there's such a small space to work with?
Traditionally, they believed that because embedded developers have thought that, well, this is an embedded device that's encapsulated in the microwave oven or the washing machine or whatever, and it's not connected to the internet, and it's really hard to infect it, and it's a single purpose thing loading a really single purpose piece of code, and no one cares. I can just ship it and forget it. But nowadays, most everything's becoming internet connected, and that puts up the risk right there. Just like any PC or server in the world, if it's an internet connected device, it can be hacked and used for nefarious purposes.
And so embedded system, like what's the adoption like for embedded systems using, or IoT devices using UEFI?
Very slow at this point. It's something that the UEFI forum would like to very much to expand our reach, and we're essentially doing a sales job at this point, trying to educate people who build embedded and IoT devices about the advantages of the UEFI approach to system startup. But most folks that are in that world today have come from the monolithic bootloader space, the U-boots and core boots of the world. And there's absolutely nothing wrong with those systems. I feel like UEFI, the UEFI approach has embedded security right into the design and architecture. It's not an add-on or a piece you get to choose to choose whether it's part of your architecture or not. You can choose whether it's part of your implementation, but it's right embedded into the standard architecture.
And what are some of those security enhancements that you would get on an embedded platform by using UEFI?
Well, the two big ones are things we've kind of talked about or alluded to anyway. The first is the secure boot functionality. Secure boot gives you the capability of using a root of trust that starts right with the CPU hardware and microcode and progresses right through, potentially all the way through the operating system boot and the application starting up, that no piece of code will run on the computer unless it's been cryptographically signed and correctly matches the keys stored in the machine. And so if anything is either hacked, damaged, or replaced, it won't run. Now, that may cause the machine not to boot, but in my take, I would much rather have my machine fail to boot and realize, oh, gee, I need to upgrade the firmware or do some sort of remediation to get it back to a safe state, rather than booting up and me not realizing that it's been damaged in some way and it attacks my network or shares my personal information or something. So secure boot is part. Then the update process that we've talked about is another part that prevents installation of unsigned updates to the firmware, and also prevents rollbacks to previous versions that may be flawed security-wise. And I think thirdly, something UEFI doesn't talk about as widely because it really kind of crosses over from one organization to the other. The reference implementations of UEFI include the support for the Trusted Computing Group's TPM chip, which allows you to do measured boot, which is very similar to secure boot, except it allows the boot to go ahead and proceed potentially, but notes the fact that any particular piece of the system is not the same as what it was before. And if you use a system uses the NIST 800-155 guidelines for authenticated boot, it could notify a remediation server of the fact, gee, I booted up and got up successfully, but something was compromised in my boot process, and this system needs to be placed on a secure subnet and attached to a remediation server who can do repairs and get it back into a good state before it's allowed to run normal code and join the normal corporate network or government network or whatever. This is an area that I think is becoming more and more important.
You mentioned the UEFI forum previously. So, obviously there's a lot of companies that are involved with that forum. What are some of the goals for that forum?
Well, the forum was formed initially when Intel, who had developed this new approach to booting up a system and the interface between the OS as it boots and the firmware on the platform, they came up with this thing called EFI. And it was leaps and bounds ahead of the old BIOS that had existed today. But the problem was, of course, it was owned by Intel, and there were those, and I think there's some reasonable fear out there in the industry that, gee, if a standard is completely owned by a major player with as much power as Intel, that maybe, they might not be something that I want to take advantage of. And Intel saw this happening, and I'm speaking for them. Clearly, I don't work for Intel, and I never have. But I believe what happened really was that they decided that no one was going to adopt the EFI standard because it was owned by them. So they contributed essentially the specification to this organization called the UEFI Forum, and their implementations to open source, essentially, with the idea of creating a collaborative industry-wide body to maintain the standard going forward so that no particular company would own it, and everybody would have an opportunity to contribute and participate and guide how that standard moved forward. It is similar to an open source kind of thing, but it's for an architecture, for a standard.
Yeah, so Intel come up with the architecture or standard, and then the companies develop their own implementation, sort of like an RFC, correct?
Very much, yes. And this has been so successful. The companies get together on regular weekly meetings in work groups for different portions of the specification. There's a security sub-team and the platform initialization team, and that working on various aspects of the process and the specifications for those. And as I said, it's incredibly collaborative. I've been involved with standards bodies across the industry, and some of them can be quite combative and argumentative, and companies get mad and start blackballing each other, and bad things happen. I have not seen that in UEFI at all. Everybody works together, and if somebody's got a concern about a new proposal or an update or change, everybody steps back and forms an ad hoc team to go off and figure it out and comes to a consensus about how this should move forward. Things have been left out because they just didn't have broad acceptance, and others, the people's concerns have been addressed, and the standards changed. So it's an incredibly collaborative and terrific environment.
And so, given that a lot of companies have their own implementations, what are some of the really cool implementations that you've seen of UEFI?
That's a tough one, honestly. It's a good question, but I don't honestly have a terrific answer for that, because a lot of times companies, the really cool implementations, they keep to themselves.
Yeah, that's true.
I know Apple is one of the early adopters and has been using EFI from before the UEFI forum existed, and they've been an active participant in the development over the years, and they use it in many of their products. But I don't know the details, and that's true of a lot of companies. They keep this very close to the vest, and I think the people may be surprised out there to realize that UEFI and the extensible firmware interface has actually been around and been on PC and laptop platforms and servers and Apple devices for many years. And there was always a BIOS compatibility mode that was available in that system. And so OEMs, the companies that build PCs, have for many years been using UEFI firmware, but in fact had a compatibility mode layer on top of it to make it look like it was still running the old BIOS. So people say, well, this is something really new, or something that only came out after Windows 8 and Microsoft started mandating the secure boot capability. Most computers, PC, laptops, tablets, and many servers and that kind of thing have been running UEFI firmware for years before that.
So what's next for you, EFI?
I think it's going to continue to evolve. In the last couple of years, the creators of the ACPI specification, the Advanced Control and Power Interface, I believe is what the TLA or the acronym stands for. That specification was owned by several significant industry players, about 8 of them, I believe, and they absolutely controlled that interface. Then that's the interface that for power control between the OS and platform firmware. And as I said, that was completely owned by a handful of companies. That handful of companies decided that the collaborative approach taken by UEFI was such a great environment for maintaining a specification that group voted among itself to go ahead and hand over the specification to the UEFI organization. And now ACPI specification is maintained by the UEFI organization. And the big move, I think, more than anything else, is to increase the bindings for both UEFI and ACPI and the various specifications that make that up to more and more platforms. A major effort has been done to broaden it to all the ARM platforms, and ARM Holdings and the various chip vendors and all have been active participants in that process. And as other processors become prevalent in the industry, bindings will be available for those, and implementations will enter the open source space of UEFI type firmware for those other processor types.
And so, we've seen the progression from BIOS to UEFI. Like, is there something that's next that's going to replace UEFI, or it kind of sounds like it's just going to continue to expand?
I think it's going to evolve and just continue to be extensible. I think that most likely, I hadn't really considered this until we started preparing for this call, but the thing that struck me is I think maybe an effort to pull out from the various specifications old latent material that was in the specifications in order to support legacy platforms that probably don't exist and are not needed anymore. So that might be my proposal to the organization, really, is to start thinking about a simplified or stripped out version, particularly targeting new emerging technology platforms.
That's awesome. So does UEFI have a regular conference? You have regular calls, but you also have regular conferences. Is that true?
We don't have conferences in the traditional sense, although we have been for a number of years, but having what's referred to as what we've called plug fests. And the idea of those initially was to get all the OEMs, the chip vendors, the hardware vendors that had plug-in cards, all together in one place at one time, and have everybody plug their hardware together and make sure it actually worked. And debug it. Gave an opportunity for lots of companies to rapidly test their new hardware to see if it met the standard and just worked with all the other devices. We've been doing those for a number of years, usually 2, 3, or 4 a year, depending on how active the market is with new devices and new software. Over time, those have been become more and more training opportunities where we bring together a lot of the engineers, the technical folks in the various companies, bring them all together in one place and talk about what's happening in the standard, new devices, new technologies, and educate people on what they need to be paying attention to as the world goes on. So they're becoming more and more of a training opportunity and less of actually plugging hardware together and seeing if it works.
That actually sounds like a lot of nerdy fun.
It is. We're having one the end of this month, and it's a members-only operation. You have to be at least an adopter member of the UEFI forum, but it's a lot of fun, and it's taking place in Seattle, right down the street from Microsoft. So they sent a lot of interesting folks from the Microsoft campus right to our affair, and get to meet and talk with those folks.
And now, Dick, you recently wrote an article for an embedded computing magazine. I believe we have the link, and we'll put that in the show notes. But do you want to just tell our audience a little bit about that article if they want to check it out?
Yeah, it was a fairly high-level piece with the intent of just letting folks know that are coming out of the embedded space and starting to do development of IoT-type devices that it's important. The platform firmware really is important, and you need to consider the security angle of it. And that if you haven't been attacked yet in this space, you probably will be. Mm-hmm. And maybe you should consider an implementation of UEFI. I know there are a lot of folks from that space that are very comfortable doing development on top of U-boot or Core Boot or one of the various other open source versions, and that's perfectly fine. And many of them have capabilities similar to Secure Boot and the Secure Update facilities in the UEFI that are available. You can put together, and there's absolutely no reason not to. The advantage, I think, for a UEFI is there's, it's part of the specification. It's been well tested, and as I said in the article, while we have seen an occasional flaw in specific implementations where somebody made a coding error, mm-hmm. No one yet, including a lot of really sophisticated security researchers and academics, have spent a lot of time looking at the code and probing the software, and no one has yet found an architectural flaw. I'm not going to say there aren't any. You
right.
A negative like that, but no one's found one yet, and that's great. And I can say that fairly definitively because I chair the UEFI's security response team that responds to any reports of security flaws or problems in anybody's product that is using UEFI firmware.
That's awesome. Anything else you want to share with our audience?
I'm just trying to think here. So UEFI is a solid, publicly available, open source. The implementations are open source. The specification is open to anybody. Anybody can join the forum and adopt the technology at no cost. And if you choose to be a participant in developing the specifications, for a company, it's a trivial cost to join, just to maintain the membership organization, the infrastructure necessary, websites, and those kinds of things. So it's a trivial cost to participate. Everyone's welcome, and we would love to have even more companies involved and add value. I think it's a flexible, modular approach to platform firmware, and it really is the wave of the future, I believe. And it's my hope that other than some very specific cases where monolithic, simple, straightforward boot solutions make more sense, in most all cases, the UEFI approach is more flexible and allows for extensibility and support of complex and simple platforms.
It's awesome. Dick Wilkins from Phoenix Technologies, thank you so much for appearing on Pulse Security Weekly.
Happy to be here, and thank you very much for the opportunity.
Thank you.